Welcome to the Geometry Unit 3 review packet. In this video, we will be covering topics 7a through C. Starting with 7a, it says use the cube at the right and list all of the possible responses. All segments parallel to EH. A good rule of thumb for determining whether segments are parallel is just to ask yourself, are they going the same direction and not touching? If we look at the cube, there's three other segments which go the same direction as EH but don't touch. And that would be AD, BC, and FG at the back of the cube. So our answers would be segment AD, segment BC, and FG. Number 2, all segments skew to segment GH. Parallel are segments that go the same direction and don't touch. Skew, while not technically correct, a good way to think about it is as segments that do not go the same direction but don't touch. GH is down here. We want segments that don't touch GH and go different directions. Well, that would be AE. It will never intersect GH no matter how far out we extend it, and they're not going the same direction. The same with BC and AD. So we'd have AE, BF, BC, and AD. Number 3, all segments parallel to segment CG. CG is in the back corner of the box, so we're looking for segments going the same direction but not touching. This is very similar to number 1. The ones that run up and down would just be BF, AE, DH. Finally, number 4, all segments perpendicular to GF. Perpendicular means crosses at a right angle. GF would be the segment in the back corner of the box. It's intersecting with two other segments. EF, which makes a right angle, and BF. Skill 7b. Using the diagram at the right, name the relevant transversal angle pairs. Then classify the angles. Whenever we see a problem with parallel lines on a transversal, it's a good idea to highlight the parallel lines and the transversal. Here, because I have two sets of parallels, I'll just highlight those in different colors, and then I'll use a slip of paper to cover up the ones that I don't need. First, we have angle 2 and 4. Here we have 2, here we have 4. Because I'm not talking about any of the angles in this other intersection, I'm just going to cover it up with a slip of paper because I don't need it. So here, you can clearly see the relevant transversal is B. And the angle pair that they would make is corresponding. 2 is in the top left, 4 is in the top left. To abbreviate, I'm just going to call it CAP for corresponding angle postulate. 12 and 8. If I use that same trick of covering up the line that doesn't have either of the angles on it, we can see here's 12, here's 8. Our transversal would be M. It's the only line. 12 and 8 are outside the parallel lines. 12 is on the outside and so is 8, and they're on opposite sides of the transversal M. So that would make them alternate exterior angles. We'll abbreviate that AE, AT for alternate exterior angle theorem. 4 and 6. There's no way that I can cover up one of the lines to show how 4 and 6 share a transversal because they don't. 4 is on line M and B. 6 is on A and N. They don't share a line, so there's nothing I can do here. So we will say no transversal. 4 and 10. 4 and 10 are in the same intersection, so I don't need to use any of my parallel line theorems. There is no transversal, so we don't need to worry about it. And these two, I'm just going to write LPP for linear pair postulate. 5 and 1. A is the line that 5 and 1 share, so A would be my relevant transversal. 5 is in the top right, 1 is in the top right. They're in the same position, so that would be corresponding. Angle 6 and angle 5. 6 and 5 share the same transversal as before. Let's see, they're not in the same position. but they are both inside the parallel lines. Both 6 and 5 are on the interior of the blue parallels, and they're on the same side of the transversal, the orange line. So the relevant transversal would be A, and these would be same side interior angles, which we'll abbreviate SSIAT. 3 and 8. 3 and 8 both share line B. So B is my relevant transversal. 3 is inside the parallel lines, so is 8, and they're on opposite sides of the transversal. That would make them alternate interior angles, which we'll abbreviate AT. Angle 3 and angle 5. 3 is on lines B and N. 5 is on. They don't share a transversal because they don't share any line at all. This is no transversal. (13 through 16). In the above diagram, A is parallel to B, M is parallel to N. Classify the given angle pairs as supplementary or congruent. Justify your answer using the correct postulate or theorem. 5 and 12 are, looking at our picture, angle 5 and angle 12 are in the same intersection. They're on opposite sides of that intersection, so that would make them vertical angles. Vertical angles are congruent. So I'm going to say vertical 5 and 12 are congruent because of the, and vertical angles is a theorem, VAT. Angle 4 and angle 7 are. Angle 4 and angle 7 share line M. So I'll cover up line N because I don't need it. 4 is in the top left, 7 is in the top left. That means they're corresponding. The rule for corresponding angles is that they're congruent, but if you ever get mixed up, you can always just look at the size of the angles. 7 is obtuse, 5 is acute, acute, obtuse, obtuse, acute, acute, obtuse. When you have two parallel lines in a transversal, if you can see acute and obtuse angles, any acute equal to any other acute angle. And the same with obtuse. Obtuse angles will always be equal to each other. And if you ever mix an acute and an obtuse, they'll always be supplementary or equal to 180. 7 is obtuse, so is 4. They're congruent. Again, quick way to remember in case you forget. The relationship was corresponding, which we'll abbreviate CAP for corresponding angles postulate. Number 15, 9 and 10. Here, 9 and 10 are in the same intersection. They're not on opposite sides of the intersection. They're next to each other. They share a side and they make a straight line. That makes them a linear pair. All linear pairs add up to 180, so they would be supplementary. By the linear pair postulate, LPP. Again, you can always use the idea that one's acute and one's obtuse, so they have to be equal to 180. Finally, for this page, number 16, angle 3 and angle 8. In my picture, angle 3 and angle 8 share B as a transversal. 3 and 8 are both inside the parallel lines. On opposite sides, that would make them alternate interiors. Alternate interiors are congruent, which you can also see because they're both acute. So angle 3 and angle 8 are congruent because of the alternate interior angle theorem. (17) Identify the angle relationship name, set up an equation, and then solve for x. Whenever you see one of these problems, the first thing you want to do is highlight your transversals and parallel lines. The transversal is the line that both angles share, which in this case would be that, and the parallels are the other lines that make the angles. For the angle relationship, both of them are outside of the parallel lines, but on opposite sides of the transversal. So this would be alternate exterior angles. Now, they are congruent. Because alternate exteriors or angles are congruent, that means that these two have to be equal to each other. Setting them equal gives me the equation 14x minus 1 equals 12x plus 17. To solve for x, subtract 12x from both sides. Add 1, and then divide by 2. Number 18, First, I'm going to highlight my transversal and parallels. Next, my relationship. Both angles are inside the parallel lines, so that makes them interior angles, but they're on the same side of the transversal. So that would be same side angles. The relationship between same sides, this one looks obtuse, it has to be supplementary. That means when I add these two angles together, it should give me 180. So using that, I can now write the equation 4x minus 46 plus 5x minus 44 equals 180. You're welcome to solve however you like. I would combine my like terms first. 4x and 5x would be 9x. 46 and 44 would make 90, negative 90. And on the other side, we have 180. To get the x by itself, we'll add 90 to both sides. 180 plus 90 would be 270, and then divide both sides by 9. 30. Number 19, transversal and parallels. First, we establish our relationship. This is in the top right corner of the intersection. This is in the top right. Because they're in the same position, that makes them corresponding. Corresponding angles postulate, and the relationship between corresponding is congruent. To write the equation, congruent means equal, so I need to set these two parts equal to each other. To solve this equation, first we'll add 15 to both sides. So it'll give me x plus 40 equals 5x. Subtract this x to both sides to get the x's together. And then divide both sides by 4, giving us 10. Number 20. Transversal parallel. Both angles are inside the parallel lines, which makes them interior, and they are on opposite sides of the transversal. So these are alternate interior, AI, AT. The relationship between alternate interior, which means I'll set these two equal to each other. Gives me the equation 8x plus 5 equals 10x minus 7. First, I'll add the 7 to both sides. Then, move the 8x by subtracting it. Finally, divide by 2. That gives us 6. The final question for topic 7a through c will be 21. Solve for x, y, and z. It's not asking me to establish any angle relationships, so I'll start by highlighting my transversal. In this case, we have 3 parallel lines. Starting off, I probably want to find a relationship between 142, the angle that I do know, and something else. Now 142 and x are corresponding, so I can use that fact to write an equation to solve for x. Corresponding angles are congruent, so that means that 142 has to equal 4x plus 6. To get x by itself, we'll subtract 6. And then divide by 4 to get x by itself. And that would give us 34. Now that we have x, we can find y, or z. 142 and y make a linear pair, which means they have to add up to 80. That gives me the equation 142 plus 2y plus 8 equals 180. To get y by itself, first I'll combine my like terms. 142 and 8 would be 150. Subtract the 150 on both sides. 180 minus 150 would be 30. And finally divide by 2. Y is 15. The last one I need to get is z. Now I can kind of take advantage of the fact that all of these angles are either going to be 142 or supplementary to 142. Well, if this angle is 142, it means this one has to be 142 as well, because these two are vertical. And if this is 142, then that means z has to be 142, because it's corresponding to this. That just gives us z equals 142.